Hello, everyone, and welcome to Unit 1, Lesson 1, Algebraic Essentials. Yes, open up your notebooks, and let's take a look at variables, terms, and expressions, Common Core Algebra 2. If you don't understand what I'm saying, you can just look at that QR code and listen to that fantastic instructor explain it slightly different. Okay, so mathematics has developed a language all to itself, and that's why it might be a little bit confusing to you. So let's clarify some concepts and remove any ambiguity from the analysis of a problem. Let's jump right in. Variable is a quantity that's represented by a letter or a symbol that is unknown. Our most famous one is X. Some of the times, we have symbols like that. The number is unspecified or it can change with the context of a problem. Okay, term. A single number or combination of numbers and variables using exclusively multiplication or division. This definition will be expanded when introduced to a higher level of functions. So let me see. 3x. 3x squared. Wait a minute, you just said multiplication. Well, guess what? Square means that we're multiplying x times x, so it is just a shortened way of saying multiplication. Now, expression, a combination of terms using the addition sign and subtraction sign. Oh, by the way, I'd also want to add on to this something like 2/3. Interesting. 2/3 is a number represented on the number line. Exercise 1, consider the expression. Now that immediately tells us there's going to be addition or subtraction symbols in it. Consider the expression 2x squared plus 3x minus 7. Good, we have addition and subtraction. How many terms does it contain? Well, let's count. You see, remember that the terms are separated by the addition and subtraction symbols. So since we have 2 additions and subtraction symbols, that must mean that we have 3 terms. Evaluate this expression without your calculator when x equals -3. Why are we doing it without our calculator? Because every time you have a negative number, we have to remember that a negative times a negative is a positive. -3 squared is 9 times 2 plus. Now, I can do that. -3 times -3 is -9. Then minus 7. So 2 times -9 is 18 minus 9 minus 7. Do this from left to right. Now, why'd I change plus -9 to -9? Because it is, people. It is. When you add a negative, you're really subtracting a positive. 18 minus 9 is 9. Minus 7 is positive 2. What's the sum of the expression? What expression? The original one. 2x squared plus 3x minus 7. Now remember to align common terms. That should be a 5. They have the same exponent, x squared and x squared. Okay. Now, since we're adding, it doesn't matter which one we do first, so I'm doing the second one first. Minus 12x plus 2. That kind of looks like a 2 squared. There we go. Double check. Make sure that I have everything right. We are adding 7x squared. You don't change the exponent when you add. Minus 9x. Positive 3 minus 12 is -9. -7 plus 2 is -5. Any questions? Just ask. Like terms, 2 more terms to have the same variables raised to the same powers. Only the coefficients, the numbers in front, can be different. Exercise 2. Most students learn to add two like terms. They simply add the coefficients and leave the variables and powers unchanged. Right. But why does this work? Below is an example of the technical steps combine the like terms. What the real property is, justify the steps. Okay, justification. What's going on here? If you look at this from right to left, look at it that way. What's going on here? Well, it looks like that we distributed, we multiplied. It's a distribution. So that's the distributive property. And then what happened? Oh, we just added this property of real numbers. You know, it's just what happens. You just add the numbers together, and then we distribute it again. Now, we also commuted because we changed order. We put the 10 in front. Okay, any questions? Just ask. Turn the page. So what this is saying is A, B, and C are any real numbers, 3, 7, 29, negative 18, and of course, 3/5. So a fraction, or a number, or 8.25, anything like that, okay? Don't forget something like -7, okay? The commutative property of addition and multiplication. Change order. The associative property of multiplication. Order stays, parentheses, move. And the distributive property. So don't get really messed up with that stuff right there. What it says is something like 3 times x plus 7 equals 3x plus 21. And it also works for division here. So 3 plus x over 18 equals 3 over 18 plus x over 18. And you can use the same thing for subtraction. So the procedure for simplifying a linear expression, ta-da! No equal sign, so it's not a linear equation. And it's linear because the exponent is 1. It's shown below. State the real number property that we just had above that justifies each step. So let's take a look at the first one and see what happens. It appears all the parentheses disappeared. Right? So here we have an 8 and an 8. Oh, there's only one 8. And so the 8 went to there and the 8 went to there. The 5 went to there and the 5 went to there. Looks like it's distributive. So now we have that and it went to there. It's really the 8 times the 2 were grouped. The 5 times the 3 were grouped. Oh, that's associative. And then they use the real number property to just combine like terms. You know, that's just. Now, let me see. We have the 16x and we have the 15x. They change order, so that's commute. The commutative property. Then, if I look from here to there, it looks like distributive. So from there to there is also distributive. Looks like we added those together and then multiplied by 31. But what really happened was there's a grouping symbol there. We can call it distributive and associative. So the first thing we did is we distributed and then we associated. No property, combined like terms. Because we use real number properties to transform that expression into a simpler form of 31x plus 29, these two expressions are equivalent. How can you test this equivalency? Let me see. Pick any number but -1, 0, 1, and 2. So pick 3. 31 times 3 plus 29 equals 93 plus 29. And then when we add those together, we get 131, 32, 132. 132. Check it for me, okay? Got it. Checked. 132. Now, we didn't complete check. We have to take the 8, 2 times 3 plus 3, plus 5, 3 times 3 plus 1. Took that. Do order of operations. 2 times 3 is 6, plus 3 is 9, times 8, plus 3 times 3 is 9, plus 10, plus 1 is 10, sorry. So 5 times 10. We have 72 plus 50 is, did I do anything wrong? Yes, I did something wrong. So this is 122. You know, I think I did that before, last year. That's 122. Remember when I said check? Because it seemed just a little bit off in my mind. And so I did check it with a calculator, and ta-da. Okay, so that ends today's lesson. We're going to do the next page tomorrow. Sorry, actually in class, sorry that it lasted a little bit longer than expected. It should only be 10 minutes. Catch you later.